Hello everyone, I am Gobinda Saha from Purdue University, and today I will present our work on Saliency guided experience packing for replay in continual learning. In continual learning, network learns from a sequence of tasks over time. In this work, a task is a classification problem. The major challenge in this setup is catastrophic forgetting, where the network only can remember the current task perfectly but forgets all the old tasks. This problem is known as catastrophic forgetting. To solve this issue, popular technique like experience replay stores some images from the past task in the episodic memory and replay them with the current data to mitigate forgetting. All the variants of experience replay differs in the way this image memory is selected and how they are replayed. The major problem with this technique, however, is they suffer when the memory size is very small. In this work, we propose a new experience packing and replay, where instead of saving the full images, we only save the important parts of the past images. We do this selection by the saliency map. We show our method improves memory efficiency and performance. For memory selection, we ask the following two questions. Do we need to store the full image? And which part of the input image is important for the neural network? We answer these questions using saliency method. For example, saliency method like gradcam highlights the part of the input important for the network classification. Using that information, we only store the important patches in the memory. In that process, we can pack the episodic memory with diverse patches without increasing the memory size. During replay, we use these patches with zero padding and jointly train the network with the current data. And that's how we reduce catastrophic forgetting in our method. Now, let's look at some results. We have used 3 datasets, each having 17 tasks. We have used ResNet 18 model. For isoepisodic memory, we achieved up to 5% accuracy improvement over the state-of-the-art baselines with least amount of forgetting. When we reduced the memory size further, our method performed well adjusting the patch sizes, whereas other methods suffered drastically. Now, let's look at some analysis. We found zero padding works better than random pixel padding. Moreover, we found exact patch placement works better than random placement. Finally, we show saliency-based patch selection works significantly better than random patch selection. Finally, we show other saliency methods like gradcam++, full grad, smooth grad can work with our method and achieve similar performance. To summarize, we have proposed a new experience replay method where we select the memory with saliency maps. We achieved state-of-the-art performance with small episodic memory. Future work should use better saliency methods and replay techniques for improving performance. Thank you for your attention.